Hello, welcome to Astronomy Live. Tonight, I'm going to be tracking the SDO spacecraft. So these are live images coming from the telescope. And if I zoom in, this is actually SDO right here, this little tiny dot. And the stars are streaks, and they're streaking by. So this is the whole image. You can see all these streaking stars. These are going to be used for astrometry to measure the position of SDO, which again is just a single pixel dot right here. These images have been dark frame subtracted to remove the hot pixels. Occasionally you'll get a cosmic ray hit that will create a fleeting speck on the image similar to SDO. But SDO is not transient, it's consistent from image to image. See here, these two dots, these are cosmic ray hits. So that's radiation that's just hit the CCD and lit up those pixels temporarily. And then they're gone. SDO is quite faint. I'm imaging here with 15-second exposures using an Orion ST80 refractor, which is riding piggyback on the main 8-inch LX200. Is occurring through the Orion ST80 with the SBIG ST2000 XCM camera. And I'm bending the images 2 by 2 to increase the sensitivity, decrease the file size, and we don't need color data for this anyway. Also, it'll make life easier on the astrometry side of things, which is also why I'm using the refractor in this case rather than the main telescope. Now, late last year, I predicted the end of the SDO eclipse season successfully using data from my own telescope. And this year, I'm going to predict the start of the forthcoming February SDO eclipse season using data from my telescope again. Lessons learned from the last time I did this, I found it was quite difficult, actually, to get the images to astrometrically solve last time, mostly because the star streaks were so lengthy, and the astrometry software expects the stars to be little points. So it can be difficult for the software to solve the coordinates of the image unless you have a lot of streaks to work with. So the shorter your streaks, the easier it is for the solver to find the location of the images. And so to shorten the star streaks, I'm using the wide field refractor. So the stars don't appear to move as much in 15 seconds, even though the satellite is moving, because you're looking here at a wider field of view, less magnification. Now, SDO itself is, of course, harder to detect through an 80mm telescope than the 8-inch main telescope. So it's just a faint little dot, but that's all we really need. We just need to know where it is in the image. And occasionally, if the tracking isn't quite perfect over the course of the exposure, it'll look a little dimmer, perhaps. But for the most part, it's pretty solid. You can definitely tell where it is. And if I lengthen the exposure, it really becomes pretty apparent. Also, if I stop the tracking, that dot goes away, which is another indication that really is SDO. Also, I should point out, the tracking is occurring based on the orbital elements of SDO, and those orbital elements, again, I generated myself, in part using data from last year and the data I collected before that final prediction, and in part using some updated data that I collected a few nights ago using itelescope.net. So using my old orbital elements, I predicted the rough position of SDO And now, since several months have transpired since that previous prediction, those orbital elements are no longer quite up to date. SDO has undergone a couple small maneuvers, dumping momentum. I think they use control moment gyroscopes on SDO. I'd have to look that up to be sure, but those can get saturated, and you have to unsaturate them by using thrusters to compensate for the rotation of the spacecraft. That's all complicated. I'm not going to get into the details of how spacecraft control occurs, but suffice it to say, they did a couple small thruster maneuvers in the last few weeks, and that can throw off the orbital elements. So can solar radiation pressure over time, perturbations from other sources of gravity, the moon, the planets. That all affects the orbit over time. And so by the time I observed it with the eye telescopes, it was about a minute off from where the orbit I had from before predicted. Not too bad. It showed up in the pictures. I took pictures over several minutes of time, and you could see the streak of SDO pass through the images where expected, just a little bit off in timing. So by loading that data into the orbital solution, I've now refined it, and I'm testing that tonight. So that is what's driving the telescope right now. The data it had originally collected months ago, before the end of the last eclipse season, and a little bit of data from itelescope.net a few nights ago. And it's working pretty nice. I mean, it's working really, really well. It's tracking SDO close to the center of the image. And earlier, before I started tracking SDO, it was actually hiding in the trees, and it just rose out of the trees a few minutes ago. While it was hiding in the trees like that, oops, contrast setting went away there. While it was hiding in the trees like that, I took this shot of the Orion Nebula and centered it up so that it was dead centered. The trapezium was actually dead centered in the eyepiece of the main telescope, and that's what's providing, of course, all the pointing, all the go-to is the main telescope. So I dead centered the trapezium in this image, and that's these stars right here. And so while they were dead centered in the crosshairs of the eyepiece in the main telescope, it showed up a little off center here in the refractor. Not too bad. That just means that the refractor is not pointing exactly where the main telescope is pointing. That's controlled by the guide scope rings that hold that refractor in place while it rides piggyback on the main telescope. But it's close enough. It gets it in the image, obviously. It gets it pretty close to the center of the image. And you'll notice that SDO is off-centered in my images here by just about the same amount. And so that tells me the tracking's working extremely well. The orbital elements are working extremely well. But for even greater precision and for greater confirmation, I'll be astrometrically solving these images using the positions of the stars and not only confirming the position of SDO, but solving its orbit using this data. And that final solution will then go into a prediction video I will make before the start of the next SDO eclipse season. The SDO eclipse season is where SDO passes into Earth's shadow. It does this twice a year for a period of a couple weeks, and for a few minutes each day. And actually, I'd have to look up the exact amount. I forget exactly how long it stays in there. It's actually, I think, over an hour that it stays in Earth's shadow. It can't see the sun. Earth passes between the sun and SDO, and the sun is blocked for a period of time. And this is, of course, quite predictable based on SDO's orbit. So there are some who have gotten a fair bit of attention on YouTube claiming that this is not normal, that this is not due to SDO's orbit around the Earth. So to address those claims, I predicted the end of the last SDO eclipse season and predicted that it would be the final eclipse would actually be a partial solar eclipse, not a total solar eclipse. Earth would just graze the sun. And that's exactly what happened. And so you can see my previous video about that. I'll drop a link in the video description after this live webcast. So that's what happened last time. So now we're about to start the next SDO eclipse season. And before that starts, I'm going to make another prediction video predicting the start of that eclipse season, showing you guys the circumstances of when it will start and what that will look like. And so to make that prediction, I'm going to be using data from the telescope as it's collecting these images tonight. Astrometrically solving them, getting the coordinates for this little dot from multiple images, and plugging that information in. Obviously, the camera, this SBIG ST2000 camera, saves the time of each image, and so I can use that along with my location to figure out exactly what the orbit of SDO is. And really, at this point, it's just a matter of refining it, and it's already pretty well refined here. So it's working quite well. So I just wanted to do this live webcast tonight as proof for future reference that the orbit that I use in that prediction video did come from my own data, not from NASA, not from the government. This comes from my own personal telescope, recording the SDO spacecraft over the course of a little while tonight, and then using that information to solve the orbit. So that's basically what we're doing tonight. It's not very aesthetically pleasing. It's just black and white images with a little dot and a bunch of streaks, but what it represents, what you're actually seeing there, is live images of the Solar Dynamics Observatory. And we'll have to see what my schedule looks like and what the weather looks like, but I would like to, I can't promise that I'll be able to, but I would like to actually capture the moment it goes into Earth's shadow when that happens in a couple weeks. And we'll actually see this dot disappear right here through the telescope. Now, I can't promise I'll be able to do that. Depends, again, on whether I have the time or not, and whether or not the weather will cooperate. Weather's definitely cooperating tonight. It's a nice chilly night here in Florida and very clear. It's actually brutally cold to me, but to anyone living north of Florida, this would probably be a mild night at best. But anytime you can see your breath here in Florida, it's brutally cold to a Floridian like me. So anyway, in case you're wondering, let me zoom in case it's hard to see in the stream. I don't want to move the box. Heck with the box for a moment. Just going to zoom in here. SDO is that little dot right there. I don't know how this is coming across in the stream after streaming compression, but it should be visible there as a fairly bright pixel. So let me see if I can load up the chat here and see if anyone has any questions. John Toby says, cool CGI, bro. Nah, bro, this isn't CGI. These are live images straight from my telescope. So I can adjust the histogram settings here to adjust the brightness and contrast, and even as I do that, the next image comes in. And this is live from the telescope. I'm not faking this. CCD Soft is a well-known program for controlling SBIG cameras. SBIG is an acronym for Santa Barbara Instruments Group. They make CCD cameras for telescopes, high-quality CCD cameras for telescopes. And that's what I'm using here, the ST2000 XCM. So no, these are live images straight from the telescope. Can I track Honda? Well, not tonight, but yeah, I do plan to do a webcast on Comet Honda, which is coming up with a close approach to Earth later this month. I should know it off the top of my head, but it's getting late now, and I can't recall exactly which day is closest approach, but I did look, and it's not really easily visible right now. Not visible at all right now. It's below the horizon, but it rises just before dawn, and I mean just before dawn. By the time it rises, it's already well enough in the twilight that it would be tricky to detect it, and it certainly wouldn't look terribly good. So in the next week or so, it'll get better and better. So hopefully, if the weather stays like this and we can keep this cold air mass over us and clear skies, in a few days, maybe a week or so, I can start to do webcasts on Comet Honda. In fact, let me pull up my planetarium program here and see when it would really be feasible. Unfortunately, as it approaches, it's not going to be convenient for most people to watch a live webcast of it because it's going to be an early morning affair. But 45p Honda. Okay, let's just see. What time do you come up? Okay. Looks like it comes up just before 6 a.m. right now. And I mean, it just hits the horizon at that point, which is right around the time twilight starts. Oops. Don't do that. Sorry, I'm just looking it up here on my planetarium software. Let's go forward. Let's say a week. Let's just say next Wednesday for the heck of it. What are we looking at here? So a week from now, it rises at 3 a.m., which is a lot better from the perspective of trying to get it before twilight really blinds you or blinds the telescope. And at 6 a.m., at that point, it's already 39 degrees above the horizon, easily well enough to view. Yeah, it's doable. That's doable. And at my location, astronomical dawn starts around 5:52 a.m. That's astronomical twilight. So it's kind of like a good point of reference for when you can expect me to generally start wrapping up a webcast as astronomical twilight or shortly thereafter. So it doesn't leave, if you wait till 6 a.m. to catch it, you're not going to have much time on it before you have to pack it up. But if it rises at 3 a.m., you got to wait for it to get a little above the horizon to really see it. But that gives you some time to work with. So I would say next Wednesday, about a week from now, would be the first point at which I can reasonably start to get some decent time on that comet. So I'll start watching then and see what the weather does. And then if I can, get up extra early and track that for you guys. And speaking of tracking things, there's an interesting asteroid that was just discovered. Now, you probably, if you paid attention to the news, you might have heard about the asteroid that passed by Earth a couple days ago, really close. And it passed within, I want to say, about 40,000 miles or so of Earth. That's not too far. It was a dinky little thing, just a few meters in diameter. But there's been another one that's been discovered. It's designated 2017 BS32. And the interesting thing about this close approach is that it will actually pass into Earth's shadow. According to Bill Gray, it'll pass in Earth's shadow at 12:53 Universal Time on February 2nd. That is basically tomorrow morning Eastern Time. At that point, it'll already be daylight here. I won't be able to see it at that time. But it's kind of interesting. For 23 minutes, it's actually going to pass through Earth's shadow as it passes by Earth. And it'll be about magnitude 13.8 at that time. At maximum, it'll get to about magnitude 13.6. That's still far, far dimmer than anything you can see by eye or with binoculars. If you have a pretty large telescope, though, you might be able to just barely spy it in the eyepiece, but you're going to need a pretty big telescope to do that. With my scope, I could easily get it with this CCD camera. That wouldn't be a problem at all. But the problem is that I can't really track it as it goes in Earth's shadow because it'll be daylight out here. But if you happen to live on the West Coast, you might have some better viewing on it. I haven't looked up exactly where it'll be at that time, the coordinates of it at that time. But it's an interesting little event that will be happening. Not this morning, but about 24 hours from now and change. A little more than 24 hours from now. So heads up on that, 2017 BS32. Oh, is this visible with the naked eye? Great question. SDO is definitely not visible with the naked eye. This sucker is dim. Even with this 80 millimeter refractor, it's quite dim to the camera. And keep in mind, the camera here is integrating light over 15-second exposures. If I looked in the eyepiece of the telescope, I wouldn't see anything. My eyes would not be sensitive enough to see this little dot. It's only because I have a very sensitive astronomical CCD camera hooked up to this telescope that it can even see anything. Maybe if I were under darker skies, I could see something through the main telescope, but it would be challenging. Let's see. Let's see if Sky Safari. Wow, I don't know if this is accurate or not. Full disclosure, but Sky Safari says this is magnitude 17.3. That is dim as heck, and it's really impressive that this little wide field refractor is picking it up in 15 seconds, if that's the case. I think that's a skeptical estimate of its magnitude, but 17.3, that's really dim. That's dimmer than the central star in the Ring Nebula, and most people have a challenging time seeing that in their telescopes. The Ring Nebula itself is visible in most amateur telescopes, but the central star inside the Ring Nebula is a challenging object to pick out. And this would be about 2 magnitudes dimmer than that, if I remember right. So really, really, really dim. Let's see, another way of putting it in perspective. That asteroid you may have heard about in the news that passed Earth a couple days ago, that was discovered around magnitude 19, not much dimmer than magnitude 17, and it only got up to about magnitude 16 or so, or a little brighter than this would be. But that's if Sky Safari is accurate on that. I just don't know. I mean, it is about the size of a bus, and it is in geosynchronous orbit. Interesting point about that. It's not in geostationary orbit. It's in geosynchronous orbit, so the telescope does have to move to track it. A geosynchronous satellite has to be situated directly over Earth's equator, and it is at an altitude where the orbital velocity is equal to Earth's rotational period, so that it appears to sit stationary in the sky. Geosynchronous orbit simply means that you're at that altitude, but a geosynchronous orbit can have any amount of inclination to it. And SDO's orbit has about 28 degrees of inclination. And that means it doesn't actually sit still in the sky. It actually traces out sort of a figure-8 pattern, which is kind of interesting. Mostly it bobs up and down as it passes through the ascending node and the descending node of its orbit. And that's because it has that 28-degree inclination. But because it's geosynchronous, its orbital period is still equal to 1 day on Earth. So it's always overhead from my location, and it's always overhead from the tracking station that downloads data from it 24 hours a day. But that tracking station does have to actively track it. You couldn't keep a lock on it if all you had was a stationary antenna. Can I get a CCD attachment with infrared to block most light? Well, yes, actually, I do have infrared filters. I have an infrared blocking filter, which blocks infrared light, and I also have a filter which blocks visible light. It only allows infrared through. Right now, on this particular telescope and camera combo I've got going tonight, I've got a UV IR blocking filter, so it blocks UV and infrared light. And the reason for that is because this is just a simple achromat refractor. It doesn't bring all the colors of light to the same focus point. And so if I allowed infrared light through at the same time that I allow visible light through, you would have quite severe blooming in the image, where you have out-of-focus light marring the image. Now, I could also go the other way. I could actually block out visible light and just record infrared. I could do that, but I wouldn't really gain too much, I think, of an advantage in doing that. Maybe the satellite would be a little brighter in infrared. That's possible, but it's not enough to really matter all that much, I don't think. Most of the time, when I'm doing these webcasts, I actually don't have any blocking filters on. I just do visible plus IR plus whatever the CCD is willing to accept in terms of the light, whatever it'll detect. And the CCD is quite sensitive beyond what human vision can see, including infrared. And with the main telescope, the Schmidt-Cassegrain, you really don't get much in the way of chromatic aberration as a result of that. It doesn't much matter, but it does allow you to detect infrared bright objects that might be dim in visible light. Yes, Gypsy52 asks if the streaks are stars passing by. That they are. That they are. So if you're just joining us, SDO is the little dot in the center here. It's now a little square of 4 pixels. Depends on how good the tracking is in each exposure. It can vary a little bit. Sometimes the mount doesn't quite track it perfectly, so it smears it out to a couple pixels instead of a single pixel. But that is the Solar Dynamics Observatory, this little square in the center. Not very bright, kind of faint, but that's it. Enhancing the contrast doesn't really help. In fact, to my eye, it actually sort of makes some of these other random noise pixels distracting from seeing it in the image. You can try to find the right contrast. Like if I go really extreme in the contrast, yeah, SDO stands out, but some of the random noise does too, so it doesn't really help it too much, I think. So it could be tricky here to find the right contrast. And paradoxically, perhaps to my eye, when you zoom out and you get a better sense of the overall picture, which is much larger than what I've been showing because I wanted to zoom in so you can see SDO. When I zoom out all the way, it really kind of stands out because it really stands out over the general noise level of the image. When you zoom in, you're also zooming in on the noise, and you kind of, at least to me, your eye loses sense of the overall picture and where the noise level is actually at versus where the signal from SDO is. And by signal, I really mean light. Signal to noise ratio. In this case, it's just photons hitting the CCD. Do Do I think Comet Honda could come close enough to Earth to affect us? No, it's not going to affect our satellites or anything. In fact, last year I did a live webcast of an asteroid that passed closer than the SDO spacecraft, closer than our geostationary and geosynchronous satellites. 2016 RB, I think it was RB1, something like that. And we did a live show. I tracked it with software I wrote specifically for tracking fast-moving asteroids like that. And so as it was approaching its closest point to Earth, did a live webcast, and we took a look at that here. Couldn't see it at its moment of close approach because, once again, it just didn't happen to be visible from here. Daylight came up, and that asteroid was not visible at that time. Just like, unfortunately, I'm going to miss out on tomorrow morning's show of an asteroid passing the Earth's shadow. That would be cool to watch. I might check and see if I can get it with iTelescope, but I have a feeling that those scopes are probably already booked up. Once people found out about that, I bet they booked up the scopes on that event for anything that might have been available. But it's worth a look. I'll take a look at that tomorrow, see if I can book some time on a telescope and capture some images of it, even if I can't get it with my own scope. With the itelescope.net telescopes, you can use telescopes from all over the world and rent time on them to capture events, which is very handy in situations like that, where you might have a very time-sensitive event that might not even be visible from where you live. But with iTelescope, you have access to telescopes in New Mexico, California, Australia, and Spain. So quite a wide coverage, and there's a good chance if it's happening in a location that an iTelescope can see it. Okay, so somebody sent me a message asking me what affordable CCD, color CCD I would recommend. They have an 8-inch f4 800mm UFO refraction. Not sure what that is. Is that a brand or personal? I don't know. I'm not familiar with that. But okay, so it's an 8-inch f4, 800mm focal length with 1.25mm eyepiece slot, and they use a T-mount and a Canon camera. I've had fun so far, but they want to, and my advice for a affordable color CCD and also the best solar filter for an 8-inch telescope like that. So you got some options. Let's I guess I'll address the first question first, which is what affordable color CCD would I recommend instead of perhaps a Canon SLR camera. And affordable, of course, is a relative term here, but I would highly recommend what I'm using here. I mean, this is just a fantastic camera in my personal opinion, the ST2000 XCM, which I usually use with my 8-inch telescope. The brilliant thing about this camera is that it has onboard guiding capability. It's got a second CCD for self-guiding, for auto-guiding. So auto-guiding is usually done with a second CCD camera hooked up to a guide scope that rides piggyback on top of your main scope. And I've tried that before, and there are some interesting pitfalls that can come up there. It sounds like a brilliant idea. It sounds like it will solve all your problems. It really won't. First of all, and this is true of any camera that you use and any kind of long exposure photography you do, you need to be properly polar aligned. I'm not polar aligned tonight. I'm actually altaz aligned because it doesn't matter so much when you do satellite tracking. What matters is minimizing vibrations, and this telescope, this LX200, is more stable in its altaz configuration. It's more resistant to vibrations. And field rotation doesn't really matter here. I'm only doing 15-second exposures, and I'm tracking a relatively fast-moving object, a satellite. So I don't care about field rotation. But normally, if you're doing deep space photography, you care about field rotation. So first step, you got to make sure your telescope's properly polar aligned. In this case, for my telescope, that would mean putting it on a wedge and doing polar alignment that way. Now, assuming you are polar aligned, you're still potentially going to run into pitfalls with auto-guiding from a piggyback refractor, and I've hit those pitfalls myself. If you use a cheap refractor like what I've got, it's got a plastic draw tube which has all kinds of flexure to it. You put an auto-guiding camera on there, it flexes the tube, and even, a small fraction of a degree shifting that tube is going to matter, because as that tube bends, as the telescope is tracking with the rotation of the Earth, the weight load on that tube is changing, and the amount that it's bending is changing, and the direction it's bending is changing. And if it's just a cheaply made refractor, you're going to have trouble. You could buy a more expensive refractor, but you're kind of doing things the hard way, in my opinion. You can also try to fix it by putting your guide scope rings, and I learned this trick at Chiefland, putting your guide scope rings around the draw tube. Instead of having your guide scope rings, both sets of you usually have like 2 sets of guide scope rings. Instead of putting them both on the body of the telescope, on the body of the refractor, put one ring around the actual focusing tube. Yes, you'll have to unlock the rail bar on that if you want to change the focus, but it will do 2 things for you. When you lock it down, it holds the focus in place very nicely, and it also provides additional stability against flexure. But you could still run into flexure issues if you go past, I don't know, a minute, depending on how floppy your setup is. So there's just all kinds of pitfalls of that. You can get rid of all those headaches if you use a camera that has self-guiding ability. At least this is what I found for myself. Your mileage may vary, but for me, the magic bullet that has made deep space photography easy and simple to do has been to use this ST2000 camera, because it has 2 CCD chips in it. One takes the pictures that you're seeing here. This is the main imaging chip. And then there's a second smaller CCD, which you can also use to auto-guide. Tonight I'm not using that. There's no need. I'm just tracking directly based on the orbital elements of the satellite. But if you're doing deep space photography, like of the Orion Nebula, like I showed you earlier, you want to auto-guide on a star, and this provides that ability. The advantage is it looks through the same optical tube as the imaging chip. It's just sitting right next to it. So any motion, any flexure that occurs in the main tube is occurring to the imager and the autoguider simultaneously. So the autoguider is automatically correcting for anything that might be happening on the imaging chip. So it just makes life so much easier. And it's made it possible for me to take 5 and even 10-minute exposures with this LX200 Classic on its original mount on a basic wedge. I mean the bare minimum wedge. Not even the deluxe wedge. I mean, it's just, that's insane. That shouldn't be possible, really. That level of accuracy. It's blown multiple minds that have come by my setup at Chiefland, and they take a look at it, and they know how much it's cost them to set up their setups and their rigs, and how much effort it's taken. And usually they come see my rig with the expectation that an LX200 should not be capable of taking the pictures that it's taking. It's taking them because this combo of the ST2000 and the 8-inch LX200 works so well. The LX200 was one of the first go-to telescopes that was really popular in amateur astronomy. And it comes with a built-in CCD port where you can plug the CCD camera into the telescope directly and provide auto-guiding. And if you do it like this with the SBIG cameras, with its self-guiding, it's a dream. It works. I don't have to think about it, really. The only issue occasionally is you just have to make sure you get a guide star that's bright enough to rapidly image in that in the auto-guide chip. But it makes your life so much easier. I did the whole SLR imaging thing, and some nights it was good, some nights it was like struggling with flexure and all these other little niggling issues that just nibble away at your time, and before you know it, you've eaten up all your imaging time on trying to troubleshoot issues, and you pack it up for the night frustrated. Uh, I've not had a single night like that with this camera. Every night I've gone out to image. The only time I've had to pack it up is for weather. I've never had to pack it up because it wasn't tracking properly or it wasn't doing what I needed it to do. As long as the weather cooperates, I'm golden with this thing. It's great. So if you can find, unfortunately they don't make the ST2000 anymore, but if you can find one on the used market, I would recommend Astromart. Go to astromart.com. It's sort of like the Craigslist of astronomy, and you can get an account there. Unfortunately, they do make you pay for accounts now. Used to be it was free. Now it's a paid account system. It's not too much money. I forget what it is, but it's not much, and it's worth every penny if you're serious about buying things on the used market. eBay is sometimes an option, and actually, I think this camera is one that I got off of eBay, but that's rare. Usually the parts I find that I need, I'm going to find them on Astromart before I find them on eBay, but search both those locations. Search eBay, search Astromart, keep an eye out. The camera's bigger cousin is the ST4000. I think that would be an excellent choice as well. It's just whatever you happen to find. These cameras can be a little hard to come by on the used market in my experience. I don't always see them available. Sometimes you'll see an old ST7 or an ST8 as well. Those are options. I think those are lower on the totem pole of attractiveness because they're generally monochromatic cameras. They're not color cameras. And I know you said in your message you were specifically looking for a color camera, and that's what the ST2000 XCM is. It's taking black and white pictures tonight because I'm binning the pixels 2x2. But it does take single-shot color pixels or single-shot color images when I do one-by-one binning. So if that's what you're looking for, the ST2000 or the ST4000, I think, are going to be your best bets. I picked this camera up for a really good price, actually. It originally retailed for about $3,000, but you can get one nowadays on the used market for no more than you would pay for a good SLR camera. So I think that's the best way to go. What do I think about Celestron? Celestron makes a good telescope if you get the right kind. I could say the same about Meade these days. I long for the glory days. I miss the glory days of Meade. The Meade LX200 Classic that I have was made in the USA. And it's kind of a well-known fact that once they started outsourcing it to Mexico, quality went down. And that's where most of their telescopes are made now, is Mexico, including the LX200 line, last I checked. Starting around the time they introduced the LX200 GPS models, they started outsourcing them, and quality control seemed to go down. This is anecdotal, but it's not what it once was. Same goes for Celestron. They're not always on the ball in terms of quality, I think. Anecdotally, I know of people who've had issues with board failures on some of their higher-end mounts that I would have expected to be a little more reliable. On the other hand, I've known people who have been very satisfied with their higher-end mounts. If you're going for quality, CGE Pro, these sorts of things. CGE Pro is one of the mounts they make. It's supposed to be really good for astrophotography, and it can be, but it can also suffer some issues. And it's true what they say. You get what you pay for. With Meade or Celestron, even their higher end stuff, it's not as high end as, say, a Losmandy or a Paramount or something like that, but you're going to be paying a lot more for those higher end, higher quality mounts. But you can get a good astrophotography rig from Celestron. You just have to be mindful of the cost versus quality. Let's see. So you're looking for a new telescope. Elvis asked, or he was the one asking about Celestron. He's looking for a new telescope. You know, it depends on what you're looking for. If you're looking to get into astrophotography like this, you know, you're going to be spending thousands of dollars, not hundreds. But if you want good quality, yeah, Celestron, I can't say that they're certainly, I don't think they're worse than Meade. Meade, if anything, probably has greater quality control problems, but I haven't checked lately. In months past and in years past, you know, Meade was really struggling financially, and they had a lot of QC problems with some of their new mounts that they were introducing. I talked to a guy who got the LX800 or something, I think it was, and he had to return it almost right away. But then the second one he got, you know, it was under warranty. He got another one from them, and it worked fine. So I guess the good news is if they fail, at least, you know, purely anecdotally, but from what I've seen, the failures tend to be pretty early on, you know, when it's still under warranty. But yeah, I suppose the lesson there is if they offer extended warranty, I would take it, whether you're buying Meade or Celestron. This telescope I've now had for over 10 years, and it's still ticking. It's had some minor maintenance cables and things, most of which I've done myself. I haven't sent it off at all. I've never sent it off for repairs. But it's still rocking just fine here. But, you know, it was made in the USA, and I think the quality was better back then. So we'll see. If you're looking for quality, I would say, you know, honestly go with the CGE Pro. The CGE Pro mount is used by many amateur astronomers. I wouldn't go anywhere below that price point or that level. So I'm using the Meade LX200 Classic. This is an old school telescope. This was before it was even possible to update telescopes over the internet. This scope doesn't have any ability to update its software online or anything like that. There's no current support for it at all. It's definitely old school. It was really the first. It wasn't the first go-to telescope. It wasn't the first consumer-grade go-to telescope, but it was the first consumer-grade go-to telescope that was actually popular and successful. And it's sort of been the progenitor for so many different telescopes out there today. It's a Schmidt-Cassegrain on a fork mount, and it can be mounted in altitude azimuth configuration or with a wedge. You can pull or align it. It's similar to a lot of telescopes today, and of course they still do make LX200s, but I think the quality is just not what it once was. There's a lot of plastic parts that used to not be so plasticky. I don't know, just not had a positive experience all the time with some of the newer stuff. But I don't know, that might have changed. It's been a while since I've seen Meade telescopes. A lot of guys migrated from that 10 years ago. No, gosh, sorry, it's been longer than that. 17 years ago, when I first started going to the Chiefland Astronomy Village for the annual Chiefland Star Party, you'd see rows of LX200s out there. It was very popular with amateur astronomers, even serious amateur astronomers. But these days, it's rare that I see an LX200 anywhere on the field. And if it is, it's more likely to be a dinosaur like mine than it is an Autostar, in my experience, because they were well made. And you can still find them on the used market. And, you know, it might not be a bad way to go. They can be had for pretty cheap these days, $1,000 maybe for a good rig. It's in really good condition. But you are buying a telescope that's over 10, 15 years old, so parts can fail. I can't guarantee you'll be happy with that purchase necessarily, even though they are reliable. Even really well-made telescopes fail once you use them enough. Everything's got a mean time to failure. So, but quality, quality, quality. I can't emphasize that enough. You know, these days, the serious amateur astronomy guys, if you go to these big star parties where these guys have these really fancy astrophotography rigs and stuff, they're all using maybe not Paramounts. I don't see those so much, but at least not in the portable sense. But Losmandys, Geminis, Astrophysics, Takahashi, you know, these are brand names that you see out on the field. You don't see a lot of Meades and Celestrons, and if you do, it's a Celestron on a CGE Pro or something like that. Yeah, Orion's very popular, especially if you're going not for astrophotography but for visual observing. Very popular and very good, I think. I've had some good experience with Orion for their Dobsonian telescopes. They even have some go-to Dobsonians, but I don't think the quality is really as good as you need for serious astrophotography. Maybe for lunar planetary stuff, but deep space like this, I don't think the drives are accurate enough on those scopes. But they're good enough for visual observing. They'll find your targets for you. So yeah, Orion, good brand, especially for visual observing. Even some of the Meades I would recommend for visual observing, like the Light Bridge telescopes. If you're looking for a truss tube, and you want it to be on the affordable side of things, you can go with that. If you want something a little nicer, you could go with the Discovery. I think is one of the name brands. I'm not as big a truss tube guy. I don't know that equipment as well, but I have seen some Light Bridges out there that seem pretty good. So depends on what you're looking for and what you're looking to do. You know, the telescope you buy if you want to do visual observing is not going to be the same telescope you buy if you want to do astrophotography. If you want to do visual observing, you want to maximize your light collecting area so you get the most bang for your buck. You're not going to be as concerned about accurate drive systems and all of that. Oh, no problem, Elvis. Glad I could help you. Hope my information's helpful. Let's see. So, apologies for the late hour, and I'm not going to be webcasting for too much longer tonight. I think I've probably got more than enough data to run this prediction, but had to get a bit of a late start since, unfortunately, I didn't realize it was going to be in the tree. I was not anticipating it being as south as it was. I thought it was going to be a little more southwest, but turns out the satellite was in the south. I should have known that. I should have looked it up based on the orbit, but from prior experience, it kind of tends to trace out a bit of a figure-8 path in the sky. So sometimes it's a little more southwest, sometimes it's a little more south-southwest. And unfortunately, its location at the start of the night put it into a tree. I had to wait for it to rise out of the tree, which took forever. But finally got out of that tree and was able to start the webcast here. Lesson there, moral of the story: check your star charts before you set up the telescope. Make sure it's not going to put you in the tree. If I had known that going into it, I probably could have put the telescope in a slightly different location. Looks like I've been going here for about just shy of an hour. So once we cross that hour mark, I'm going to start thinking about wrapping up here, perhaps. Yeah, for whatever reason, it seems like the histogram setting that I pick for one image automatically applies itself to the other. Or at least it does when a new image comes in. But on the right, you have here this picture of Orion and the Orion Nebula and the Running Man Nebula. So, oops, didn't mean to click on it. Go back. Yeah. Okay. So the Orion Nebula is here, and the Running Man Nebula is down here, and it's kind of interesting, amazing. It's kind of amazing, really, how much you can accomplish in just a few seconds with a fast, wide field refractor like this. What is this thing? I don't even know in terms of focal ratio. Let me check and see here. I don't know. I'd have to look it up. The little sticker that used to be on it that gave me the F ratio is a bit marred up these days, but it's like maybe an F4, F5 refractor. I don't know. Really kind of fast optical system. And so this picture on the right, this was a 30-second exposure. That's it. In 30 seconds, it's already picked up all that nebulosity and even a good portion of the Running Man Nebula. Now, this is also binning at 2x2, which increases the sensitivity as well. But, for quick casual observing, you can bounce from dim object to dim object in 30 seconds with a camera like this, because it's much more sensitive than your eye is. The quantum efficiency conversion of photons into electrons very high with a CCD. And when you bend the pixels 2x2, you're increasing the size of your light buckets, essentially, on that CCD, grouping them together for increased sensitivity. You cut your resolution in half, and you lose the color data, but you gain sensitivity. So, the nice thing about a camera like this again is an SBIG ST2000, is it's great for high quality images. You can take really nice color images of deep space objects. That takes time, more time, because you're not working in a monochromatic 2x2 bending situation, but you can also bin it down and just have some fun with sort of live observing like this, whether you're tracking satellites or looking for deep space objects. Given how much of the nebula I'm picking up here, it almost wouldn't surprise me if the satellite really was as dim as Sky Safari said it was, just because of how well it's really working. So I know the webcast tonight's not the prettiest object ever, but hopefully you guys were able to get something useful out of it in terms of information, and for those looking for telescope equipment, give you some idea what to look for. Where am I viewing from in Florida? Well, let's just say near Tampa-ish. There's plenty of light pollution down here, which, again, I'm not even using a light pollution filter tonight. I don't have any kind of, I've got a narrowband light pollution filter, but I'm not using it. And so even in spite of all the light pollution, and there's quite a bit here where I'm observing tonight, in spite of all that, you're still able to pick up all that stuff. It's great. So, light pollution, not too concerned about it tonight. Not really going for super high aesthetic quality here. We're just trying to get data on where this little satellite is in space. So, don't really need to go out to the dark sky site. But yeah, for for more serious imaging of deep space objects, high quality imaging, yeah, I'll head out to a dark sky site that's about an hour away and set up there, far enough from the city that you can start to get away from the light pollution a bit. It's not perfect. It's not as good as, say, Chiefland Astronomy Village, which is up near Ocala. It's about 45 minutes to an hour from Gainesville, I think. It's pretty dark up there. Pretty darn good. It's not great. I mean, it's not as good as, say, being in the middle of the desert, but it's really good for Florida. And I would say my dark sky site, my usual sort of go-to site, which is just an hour away, that's mediocre. It's somewhere in the middle. You can see the Milky Way there, but you're not going to you're not going to be as amazed with it as, say, you would at a true really dark sky site. Something like Chiefland, where the Milky Way is just so bright and so full of stars that you lose yourself. The first time I went out there, I'll never forget it. I thought I knew how to locate my constellations. I knew how to identify the major stars. There were so many stars that was sensory overload, and I lost track of where I was even looking, which was kind of disconcerting because I was used to being able to easily recognize there's, Orion, there's Capella, there's Auriga, whatever. No, once I headed out there, it was lost in a sea of stars at first. Nowadays, of course, I'm used to it. I can find my way around even there, but I highly recommend any city dwellers like me, you have to go out to a dark sky site at some point in your life and really appreciate it on a moonless night. You have to time it so that the moon's not out and really take in the Milky Way. Try to pick a time of year where the Milky Way is nice and invisible, if possible. Here in the wintertime, we don't really have much of the Milky Way available. But during the summer, Florida the weather tends to be a little poor. But, maybe early autumn, sometime around there, and you can still see the Milky Way early in the evening. Here in Florida, up at Chiefland, you can really just be floored by how beautiful it is, especially if you're like me and you grew up in light polluted cities where you really couldn't see it all that well. So all right. Well, do we have any more questions? Any last minute here before I wrap up? Doesn't look like we have any takers. Well, thank you guys for joining me tonight. It's almost 1 a.m. here, so I'm going to pack it up and head in. But thanks, guys, for joining me, and I'll be doing another video shortly using the data that we collected here to solve the orbit of SDO and make a prediction about the start of the next SDO eclipse season, which will be starting here shortly in a couple weeks. Thanks for watching. Clear skies, folks. Please like and subscribe if you enjoyed this webcast, and stay tuned for more.